Okay, morning everyone. Great. Morning there. Are you able to hear me?
Yeah, boss.
Okay, great. Okay, so we have to continue our work of yesterday. We were talking about the geometrical construction. We spoke about the ellipse yesterday. The previous day we spoke about the construction of what? Circles in contact, bisecting of lines, plus the ellipse. So we are all building all this to form one full drawing. So we did the bisecting of lines, parallel lines, we did the ellipse, now we are going to do the polygons. Okay? We are going to do the polygons. Then we'll focus on exercise until we are perfect on this. Because I see there is a lot of ups and downs. Doesn't matter who you are, but that is what I've observed. Okay. So, on the construction of an hexagon, we need to look at when given side and when given the metric diameter. So metric diameter, for example, if you say M20, what is it that we need to do when you are given measurement like this? Okay? If we see that we have put a lot of time, we will leave this for the next day. So that we don't combine them, we need to make sure that we understand to the fullest one aspect. Okay? Are we all set?
Yes.
Okay. So now, on the polygons, if I have an hexagon, 6 sides, there must be equal sides, né? If my drawing is equal sides, it's okay. We have got 6 sides. Okay? When we are talking of when given a side, we are talking about a side like this. When given a side, let's say this one we say is 20. How do you construct such a polygon when you are given a side? There are so many methods you can use, but the quickest methods you can use. Are we together? Let's say you don't have set squares. How can you approach it so fast? So what you need to do when you're given a situation like this one, né? You need to know that a 6-sided figure has got 60 degrees angles all around. So if you come here, you check this angle. That angle is what? 60 degrees. If you draw a line to the center, these angles are what? 60 degrees. So all the angles are equal. You understand? So what it means is that this is also what? 20. Because the triangle that is formed there is what? Equilateral triangle. All the sides are what? Equal. So if they are given a side for an hexagon, you are given a side, don't even stress. That side is the radius. So how do you approach this one when you're drawing? As usual, you start with construction lines. So, you draw center line. Center line. Allocate the center. They have given you a side 20. So it means your radius is what?
20.
Your radius is 20. Are we together there? Huh?
Yes, sir.
Yes. So your radius is 20. So what you do, open your compass 20. Take your compass, When I talk of a compass, by now you should know, this is a compass. Open your compass. One side is sharp, another side is a pencil. Open a compass 20. When you open a compass 20, draw a circle. Draw a circle. That is why I've been explaining draw freehand, freehand, freehand. It's because of this. You'll be teaching and you'll be using freehand. You need to practice that. Okay? So you draw a circle, 20 radius. Because the side and the radius is the same size, so 20 is the radius you used to draw. Now, after you draw with radius 20, take that same radius. Look at the sitting. How is this hexagon sitting? It has got a flat side this side, ne? Yes. So come with 20, come here. Same radius, come here, mark this side, come here, mark that side. And mark this side, the same, mark that side. Done. Join the markings. So you join them. You join.
Sir, please repeat, how do you do the markings?
Thank you. When you are doing the markings, your compass, you need to check first how is this one sitting. The flat side is at the bottom, ne? Can you see? So when you're marking, it means your corner is here. Put your compass, your sharp point of your compass there, and mark this side. And mark on top. You put it here, because it's your corner. If your hexagon was sitting like with a sharp point like this, you are going to put your compass here and mark this side and mark this side. But because it's sitting with a flat side, we are using this point for your compass and this point, these 2 points only. So when you put your compass there, you open to the center, mark this side, mark this side. Come here, mark that side, mark that side. Does it need you to have set squares? No. Are we together? So you join these points. That is how you draw an hexagon. When you are given what? Side. Is that clear?
So, sir, if it says M20, it means the
I'm not yet there. That's why he has said what?
oh, trigonometric diagram.
Yes, here I'm dealing with the scenario I. When given the side. Is that clear, all of us?
Yes.
When you are given the side, it is a very easy method. Very easy. The circle that you draw outside, it's called what? It is a circumscribed circle. But you need to know, in AutoCAD, there is inscribe and circumscribe. So you need to know this. But the big circle is outside, and you mark on the edge of the circle to get the point. Is there any question you'd want to ask me? Feel free. I will not bite you. Is there any question there?
No.
Yes, sir.
Yes, sir.
So I wanted to ask in terms of drawing the hexagon, when do I draw the line outside of the circle and inside of the circle?
I'm coming. When you are dealing with a given side,
Yes.
it means the corners are touching the circle. When you are given this metric diameter, the corners are outside the circle. The flat sides are touching the circle. Does it make sense? You see, as I will explain this one. That's why I've separated them like this. Okay, so I'll do this. Sorry. Now here. Then the circle is what? The circle is inscribed inside the hexagon. The hexagon is circumscribed outside the circle. Here the circle is circumscribed outside the hexagon. The hexagon is inscribed in the circle.
So are you still using the same method drawing the hexagon?
No, here I haven't yet explained. It's the same hexagon, but I'm dealing with point number 2. I've dealt with point number 1 using this method when they have given you a side. A side. Now here we are dealing with the point number 2. Here given side. Here given what? Metric diameter. So let's say this one is M what? M20. When they have given you to say M20, what does it mean? When they have given you to say M20, what does it mean?
I think the size of the nut.
Of who?
The nut. The size of the nut.
The size of a nut.
Yes.
Is that all? When they have given you M20, it means its metric diameter. It represents the shank of the bolt or the drilled threaded hole of a nut. Are we together? So if a bolt is if this is the head of a bolt, you have this is the bolt. Ne? Remember, we are learning to know, not just to pass. Ne?
Yes, sir.
This diameter from there to there is the one we say what? 20. But the distance from there, this distance here, this distance is this one. Because when I'm looking from this side, I'll see this face and this face, these two. When I'm looking from this side, I'll see 1, 2, 3. Can you see the difference? So if I want to draw this face here, I'll show the three points here. Now, I'll come to that. For now, I just want you to understand what is M stands for. M, the 20 is the shank diameter of a bolt or the drilled hole of a nut. Now, how do we use this information to draw? So, for us to get this diameter is equal to 1.5 times what? 20. The metric diameter, out there. So this is equal to what? 30. Your calculators, they make your brain raise now. This is it, 30. So the diameter of this circle here, inside, inscribed circle, it's what? 30. Not 20, it's 30. Whatever I'm explaining here, I'm not going to explain in mechanical. Are we together? Because you'll find again in mechanical the same story when you're drawing in the section. So, this diameter of the inscribed circle, it is 1.5 times 20. What about the thickness of a board? Thickness. Thickness is equal to what? 0.7 times 20 is equal to 14 millimeters. That is thickness of a board. Yes.
So, sir, whenever we're calculating the diameter or the thickness, we use those 1.5 and 0.7.
That is the standard across the world. The whole world. You understand it? If it is a nut, the head is the same except the thickness. If it is a nut is 0.8 because you drill the hole. So you reduce its strength. So for a nut, thickness is equal to 0.8 times 20 is equal to 16 millimeters. So a nut, the thickness is thicker than the head of a boat. A nut thickness is thicker than the head of a boat. Are we together there? Students online there, are you there? Can you understand me? Huh?
Yes.
Okay. So, do you understand this, guys? Are you getting what I'm saying? I don't want when we give work to say, sir, what are the measurements of a nut? No, I don't want that. I've explained. You must keep it in your head.
So 0.7 is the thickness of what, sir?
Sorry?
That 0.7.
0.7. This is for boat head. This is for a nut. 0.7 times. Please, 20 keeps on changing. Why we are using 20 is because it's M20. If it is M36, you'll be using 36 there.
So, sir, in the exam, they won't be like the same numbers, they're going to change.
They change. They can say M10, M8, M16, M20, M24, M30, M36. So whenever you see the word M something, you need to know that the M is for that. The rest, I need to calculate the diameter. I use 1.5 times Z. If it is 36, you put 36 there. Are we together? If it is 30, you put 30 there. What I mean is, take a photo, I change something.
Sorry, sir.
Okay.
So, if it is I change here to M24. Like in the question there, you have M what? In the work I gave you, it was M what?
24.
24. So if it's M24, you put what here? 24. You put what here? 24. You put what here? 24. Why? Because it's M24 now. So 24 times the 2 times 1.5. What do you get? 36. So 0.7 times 24. 16.8. Then E times 8.
19.2.
19.2. So can you see how they change, right? So the 1.5 is standard, 0.7 is standard, 0.8 is standard for a nut. The only thing that changes is the metric diameter. Is that clear? Clear. Okay, thank you. I wanted to make sure I explain that. It doesn't matter it is a 6-sided, 5-sided, 4-sided. Your calculations, therefore, for it, this is mostly the boat and nut, you find them hexagon shape. If it is 4-sided, it's even easier. Okay? The thickness, please maintain. They are the same information. unless where it has been changed somewhere or explained to say you need to use these standards. But this is what we work with. Is that clear?
Yes.
Any question? Take photo of this. I need to erase so that I can utilize the space. Okay. You can, so that you start it again when I'm explaining the other.